Hello, my dear students. With the continuation of previous part, in which we started the mechanical properties of engineering materials, so we'll see in some another mechanical properties in the part 3. Just let's start. So the next property is hardness. It is a very important property for the material, for the surface of the surface loading, such as it is defined as the ability of the material to resist scratching or indentation. We'll see what is indentation. What is indentation? By another hard body. So hardness is directly related to the strength, but this strength is for the surface of the material. So we can see in this picture in which two balls which are harder than these materials and which are going to indent means going to be impressed on the surface. So this force is if the this ball is going inside by this much of thickness, but this ball is going up to this thickness. So which material is said to be more hard, this or this? And this is the harder than these materials and it is going to be indent on the surface. So which material is more hard? This material is soft because this material is inserted more to the more depth, and but this is for less depth. So this material is more hard and this material is soft. This material is softer. So this is the hardness in which material will resist for the scratching and indentation, and this type of property is used for the used in the various tempered glasses and gorilla glasses of the mobile phones, which is which resist the scratching of the screen from the various suppose if we put our phone in the pocket and there is already in some keychains are there and coins are there, so that will resist this hardness property will resist the scratching from the keychain or something like coins to the screen of the mobile phone. So that kind of properties are included in the gorilla glasses and tempered glasses. Next is the creep. This is the slow and progressive deformation of material with a time at a constant stress is called creep. This up to this point we just correlate this stress with the load, and we will study this what is stress in the next topics in the next part of this topic engineering materials. So this it is a slow and progressive deformation of a material with a time at a constant stress is called creep. So we can see in this picture that this is a material and this is a constant load. We can see in so many like bell, there is a bell or any hanging items which is under a constant load, it will not fall down and it will not fracture down. Why? Because there is a room temperature and it will not show the phenomena of creep. And if we increase the temperature here, this will gradually at start very gradually it will going down and down and will finally it will break down because of higher temperature in at this place. If we increase the temperature more, then this deformation occurs at very fast rate. So this is known as creep. Means if there is a constant load is there, but material will not fail if the temperature is not vary. But if we increase the temperature, this will fail at a constant load. So if we can see this, this is a graph. This is a graph of creep curve. This is known as a creep curve, in which we can see this is a primary curve and this is the secondary and this is tertiary. Here it is a time and this is there. Here is a deformation of the material. This is known as the percentage deformation. So in case at a starting time the deformation is very slow and it is going to be constant like this, and at, at the end in the tertiary region it will deform very fast. It will deform and finally it will fracture here is this point. And in tertiary the rate is high, in secondary rate is almost constant, and in primary the deformation is very slow. So this is known as the creep curve. The next one is fatigue. Study of the material under repeated or reversal stresses. Repeated means the force is increases and decreases, or if the force is compressive, and the next cycle it will tensile, compressive, tensile, and maximum value, lower value. If the force is applied on the material in such a way, then the material is said to be in the fatigue. If the material is very resisted to the this fatigue phenomena, then material is known as the higher fatigue strength material. So the machine parts are frequently subjected to the various stresses, and it is important to know the strength of the material in such condition. Means in that condition means if the forces are applied repeated or reversal nature, then the material strength will decreases. So in that case, we have to know what is the actual strength of the material in case of repeated and reversal cycles, means reversal forces or load. Right now we just correlate with this stress with the load. So if the repeated or reversal loads are applied on the machine components, that machine components will fail very earlier in static condition. But here if the repeated cycle, then material will be failed, but in that case the strength of the material will be decreases. So that kind of strength of the material is to be find out. So that strength is known as the fatigue strength, and the maximum stress at which the material will operate indefinitely without failure is known as endurance limit or fatigue limit. So we have to remember this endurance limit or fatigue limit. So we can see this is the stress. This is stress, and it is applying at a high maximum value, and is going at a minimum value, maximum value, minimum value. And this is the value of forces which is applied on the material and which causes a sudden fracture at lower value of forces because of fatigue loading. So next is machinability. The ease with which a given material may be worked or shaped with a cutting tool. So remember this cutting tool. With cutting tool, if we provide a shape or work, if we do work on the material with a cutting tool very easily, then material is known as a very good machine, having a very good machinability. The machinability depends on the chemical composition, structure, and mechanical properties. If material is more hard, then it is not a machinable material. If material is more tough, then it is also not known as a machinability. Much having no more machinability, because if the it is material is a more tough, means it will fracture very for the fracture for the to be machinable, the material must be fractured because due to cutting tool. So if material having a very high material is a very high tough, then material will not fracture, so it will not having a machinability. The next is weldability. It is the ability of the material to be joined by welding. The weldability depends upon the chemical composition, physical property, and heat treatment to which they are subjected to. So thank you for the this lecture for on mechanical properties. So now we'll study the stresses and strain in the next part. Thank you.